Welcome to True Projects. In this video, we are going to explain about the project which is malaria detection using image processing and machine learning. Malaria is a life-threatening disease affecting millions of people globally, particularly in regions like Africa and Southeast Asia. Current manual diagnosis methods are slow, error-prone and resource-intensive, leading to delayed treatment and potential misdiagnosis. This project addresses these limitations and provides an efficient automated solution for malaria detection. By leveraging image processing and machine learning techniques, we automate the identification of malaria parasites in blood samples. Here we integrate image acquisition, pre-processing, segmentation and feature extraction, and then we implement machine learning classifiers for accurate parasite detection. Accelerated and more reliable malaria diagnosis, timely treatment and improved patient outcomes, reduce instances of false positives and false negatives are the advantages of this project. The primary objective is to develop an automated malaria detection system using SVM, which is support vector machine, CNN, which is convolutional neural network, and CNN with SVM, significantly improving the efficiency and accuracy of malaria diagnosis. The ultimate aim is to employ these algorithms for feature extraction and classification, image analysis and synergetic combination of CNN with SVM to enable accelerated and reliable malaria diagnosis, ensuring timely treatment and minimizing occurrences of false positives and false negatives. The overarching goal is to contribute to the global effort to control malaria by improving patient outcomes and reducing the disease burden through advanced automated diagnostic techniques. Coming to requirements, we need hardware requirements and software requirements. In hardware requirements, operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above are needed. Coming to software requirements, we need Anaconda 3 and Visual Studio Community version. In the flow of project, we have designed few modules to implement the project. First one is importing the packages. This module involves importing essential libraries and modules such as NumPy for numerical operations, Pandas for data handling, Seaborn and Matplotlib for data visualization, CV2 for image processing, scikit-learn for machine learning tasks, and TensorFlow for deep learning. Coming to exploring the dataset for malaria parasite image data. In this step, the dataset containing images of malaria parasites is explored using Pandas to understand its structure and contents, which is crucial for subsequent data processing. Image processing using OpenCV. This module involves utilizing the OpenCV library to perform various image processing tasks, such as resizing, normalizing, and filtering to prepare dataset for analysis. Visualization with random sample. This step involves selecting and displaying random samples from the dataset using Matplotlib and Seaborn to gain insights into the nature of images and their characteristics. Coming to splitting the dataset into train and test. This step involves dividing the dataset into two subsets using scikit-learn, one for training the machine learning model and other for testing its performance. Coming to building the model, this module involves constructing a support vector machine model using scikit-learn, a machine learning algorithm to classify malaria parasite images. SVM. It is a supervised machine learning algorithm that is used for classification tasks. It works by finding a hyperplane that best separates data points into distinct classes. The goal is to maximize the margin between the classes while minimizing misclassifications. It is used for its effective binary classification abilities suitable for distinguishing infected and uninfected blood samples. Coming to training the model. In this step, the SVM model is trained on the training dataset using scikit-learn to learn patterns and relationships within the data. Exploring the dataset for malaria parasite image data. This exploration of the dataset likely to ensure compatibility with the upcoming image processing and building the CNN model. Image processing. Using image data generator based on trained data and test data. This module involves using the image data generator from TensorFlow to pre-process image data based on the training and testing datasets, typically including data augmentation. Building the model. Here, in this step, we build CNN and CNN with SVM model. CNN is a deep learning algorithm specifically designed for image analysis and recognition. It comprises of layers of convolutionals, pooling, and fully connected layers. CNNs use convolutional operations to detect features in images and learn hierarchical representations. It is employed due to its proficiency in automatically extracting relevant features from images crucial for identifying malaria parasites. Combination of CNN with SVM. In this context, combination of CNN with SVM implies using feature extracted by your pre-trained CNN as input to an SVM classifier. This approach combines the feature learning capabilities of CNN with the classification power of SVM. Combines the feature learning capabilities of CNN with the classification power of SVM for more accurate and efficient malaria parasite detection. Coming to Flask framework with SQLite for sign up and sign in. Here, the Flask web framework is used in conjunction with SQLite is a database to create a user registration and authentication system for application. Coming to user gives input as an image. This step involves user providing an input image to the system like for malaria parasite detection. Given input is pre-processed for prediction. Prior to prediction, the user input image undergoes pre-processing, which may include resizing and normalization to prepare it for analysis. Coming to train model is used for the prediction. The machine learning model, specifically CNN model with high accuracy, is employed to make predictions on the pre-processed user input image. The final module, which is final outcome, is displayed through frontend. The result of the prediction indicating the presence or absence of the malaria parasites is presented to the user through the web application's user interface. For execution of the project, we need to open the code folder. This is the code folder of the project, which contains the source code files. This is the static folder. This folder consists of the files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, which represent different pages of the website. This is the app.py file. This file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. This is the model file, which will be containing algorithm information, and this will be loaded into the project code during runtime. And this is the notebook.ipynb file. This file is a Jupyter notebook file, which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells. This is the sign-up file. This file is the database file used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. Now we will copy this, and now we will open the Anaconda prompt. So here we will use the cd command followed by the space and paste the copied path. This command is used to change the current directory to the code folder's path. Now we will click on the button enter. So the current directory is changed to the code folder's path. Here we will type python space app.py. This will compile app.py file. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. Now we will click on enter. After running the app.py file, the Flask framework will host the application locally at the default address, which is 127.001, this one, which is the local host, and this is the port number, unless configured differently. Now we will copy this link and paste it in any web browser. I prefer Google Chrome, so I will paste it in that. Here I will paste the link and click on enter. So this has redirected to the home page of the project, which is displayed in the web browser. Now we will click on the button sign up. So here we need to fill all these registration details if we are registering newly. I have registered already, so I'll directly click on sign in. Here I need to give my credentials, which are username and the password. And now I will click on login. So this has redirected to the home page. Here we need to upload the file which has the disease and then click on upload. Now we will upload the images. Now we will click on choose file link. So from here we need to select the image. So I will select this image and click on open. Now we will click on upload. So it has predicted that the given image is detected as uninfected blood cells, which means it has no malaria parasite blood cells. Now we will upload other image and see what will it predict. Now we'll click on choose file and select the image. I'll select this image and click on open. Now I'll click on predict. So for this particular image, it is predicted that the given image is detected with the parasited blood cells, which means it has the malaria disease. In this way, we can upload any infected images. For that image, we will get the predictions whether they'll have the parasited blood cells or the normal blood cells. Now we will close this. This project has successfully addressed the critical need for an efficient and accurate malaria detection system. By leveraging a combination of SVM, CNN and CNN with SVM, we have achieved significant progress in automating malaria diagnosis. Notably, the integration of CNN into our approach has yielded commendable results, with CNN achieving good accuracy in the identification of malaria parasites in blood samples. This underscores the potential of deep learning techniques in medical image analysis. Overall, project has demonstrated the feasibility of using advanced algorithms for image processing and machine learning to enhance malaria diagnosis. The combination of speed, accuracy and reduced instances of false results holds great promise for improving patient outcomes and contributing to the global fight against malaria.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.